Today we're going to talk about creating our own exception classes and throwing our own exceptions. So in the last class, we learned that we can write code that might throw an exception. So what we do if that code is going to throw an exception is we wrap it in a try catch. So we learned to catch exceptions. We can also throw exceptions. So if during our code, we run into a situation where something happens and we feel like something is wrong and we want to throw an exception saying, this needs to be handled, we can throw our own exception. Now we can create our own exception type, or we can just create the exception class that all the exceptions extend from. The exception class takes in the constructor a message, and this is the message that gets printed out when we call the getMessage method. So let's give it a try. So what I did here was I created a bank account class, and one of the things about constructors is that constructors cannot return anything. So if I have a set method, right now we learned when we write our set methods, we usually make them void methods. So if I say set balance, let's say float b, and what we used to do in our set methods, I would just say my balance equal to b. We didn't do error checking. We kind of assumed that whoever creates this bank account object will do the error checking for us and make sure that they give us a good balance. Now what we could do is instead, change this void method to be a Boolean, and then add a check here. We could say if balance is greater than 0, then we're gonna set it, and we will return true. Okay, so if you give me a good balance, I will save it, and I will tell you that I succeeded by returning true. Otherwise, I will print an error message, system.out.println invalid balance plus b, for example, and return false. Now, this assumes that whoever here I'm trying to create a bank account. Let's say, after creating this bank account, I go and I say account.setBalance to -100. Okay. Now, this is going to assume that someone is actually checking what set balance is returning. But here I'm not. So this error message that gets printed, might get lost, and no one is checking the return statement, so no one's going to pay attention to it. Remember also that when you're running into programs, like if you're running Word or PowerPoint or Google Chrome, where are these system.out going? They're not really printed to the screen for you to see. So those system.out println lines, those are more for, when people are running from command line, which people don't do right now. You don't usually open up a command window on your computer and start typing commands to do things. We don't do that anymore. We use GUI. And so in the next chapter, we're going to learn how to use the GUI, and those system.out println lines are not going to mean anything for us. So we really need to be checking the return type. Now, if someone doesn't check the return type, this error message is going to get lost, and we're going to be wondering, why is the balance not set? So to force code to actually do something about an error message that we run into, what we do is we throw an exception. So again, we're going to go back to our void method. Okay. So all this code will take it away. What I can do is I can throw an exception. So here I can say if balance is greater than 0, it's good. I'm going to save it. Otherwise, I'm going to throw an exception. So I'm going to say throw exception, and here I'm just creating a new exception. So I'm going to create a new object. And I'm going to give it an error message, invalid balance plus b. Now, once I do that, it's going to tell me here that you're throwing an exception. It must be caught or declared to be thrown. So that means I need to tell everyone in the world that set balance throws an exception. So I'm going to here say throws exception. So I'm going to world know that I'm throwing an exception. I could also do that with my constructor. Constructors are methods that return objects. They don't return true or false. So I couldn't even do the Boolean return for set balance like I would have for set balance. So here I can again say if the balance is greater than 0, set it. Otherwise, I'm going to do the same thing. I'm going to just throw an exception. Let's see what this is going to do. So here I'm throwing an exception if something happens. So I'm forcing whoever wants to use bank account to handle this exception. When I come back to my main, I find that it's not compiling and it says unreported exception must be caught or declared. So one thing we can do is say throws exception, kind of like we did with files. So if I run this code and I try to create a bank account, -10, it throws an exception. It's coming from the constructor call in my main. It goes into the constructor and it throws the exception. And now it's giving me a message, invalid balance. Now I don't want to do that. You know, we learned that we should be catching exceptions and handling them. So adding throws exception is not what I want to do. I want to be able to handle it. So I'm going to come to my code and I'm going to say, try executing all this code. So I'm going to wrap it all inside of a try. And then I'm going to say, if any exceptions happen, I want you to catch them. Here we will print the exception.get message. So now if we run this code, I give the name and the bad balance, it says invalid balance, -10. So I was able to catch the exception that my constructor threw, and I was able to get a message out of it. So we can write now code that throws its own exceptions. Okay. Now you could just use the exception class like you wanted, like here, like what we did. Or what we can do is we can create our own exception classes. So if you want to create your own exception class, you can. The only thing you have to do, well, you have to do two things. The first is that you have to extend exception. So this is the parent class. So we're going to use inheritance to extend from the exception class. And then in our constructor, what we are going to do is call super. And when we call super, we are calling the constructor, the parent constructor, an exception. And we are going to give it the error message that we want. And the nice thing about writing your own exception classes is that you can write different constructors so that, you know, however the code comes to it, it can print it out. So let's do that. So I'm going to come here to my package and I'm going to create a new file. And it's a normal Java class. And I'm just going to call it, let's say, balance exception. Okay. So this is my class. The first thing I do is I make it extends exception. And then I start writing my constructor. So the first constructor I'm going to write is just the empty constructor. So balance exception. And here it doesn't take anything. So it's just going to call super, the parent constructor, with invalid balance. Now, sometimes I want to actually give it a balance so that I tell it which one is invalid. So here I'll add another constructor that takes the balance. And now it's going to actually be telling me what the invalid balance is. I could maybe even add another constructor that, you know, says who the owner of the account is. So I can say string name, float balance, and then this one will call super. Trying to set a balance of that for account owner. And then this one maybe invalid balance to start with. So let's have different places in the code use these different constructors. So if I go to bank account, I might, in my constructor, throw a new balance exception and just give it the balance. Here in my set method, I might use the other constructor balance exception that takes the name and the balance. And so if I run this code and I try giving someone, a negative balance, it says invalid balance to start with. So it's going into the constructor and calling the balance exception constructor that only takes one item, which is this one, and it says invalid balance to start with. So this is the one that it's throwing. This is the exception that's being thrown. If I run this code a second time and now give this person a good balance, but my main, after it created the bank account, it tried setting the balance to -100. Now this went into the bank account set balance method, and that threw this exception, the one that takes the name and the balance. So it's going to the balance exception with the one that takes the name and the balance and says, ooh, no, it's giving the wrong one. Let's go back and check why that is. Let's see, is my main right? Let's print it and then set the balance just to see what's going on. Let's try one more time. Cat 10. I think my constructor has an issue. What is going on? Let's put a breakpoint in the constructor and see what's going on. It's not coming into the constructor. What is, oh, sorry, I need to debug it. Okay, let's try again. So it's coming here, setting the name. The balance is 10, so it's greater than 0. Balance is greater. Oh, does everyone see what I just did? I checked the balance, which doesn't exist. It should be B, the B that's being passed in. Okay, let's try that one more time. So here, let's try again with cat and 10. Well, let's try the first one again, -10. We got that invalid. And now let's give it a good balance to start off with. So now the balance is 10, but when I try to go and set the balance to -100, it went into the set balance method. It found the balance was less than 0, so it threw the balance exception that takes a name and a balance as input, and so it gave me this error message. So this is the advantage of writing your own exception class, is that you can have different constructors so that you can use those different constructors in different places when you are throwing these exceptions. Okay, so this is how you can write your own exception class. You can throw exceptions, and you can catch these exceptions the same way as before. Okay, so here the error message is coming that I decided what the error message is going to be. Now, the other thing that I want to show you is that you can have try and catch instead of another try catch nested exceptions. And at first it would seem like, why would we ever want to do that? Well, one example where we do want to do that is when you have an exception being thrown that doesn't have a message. So remember when we were doing the scanner example last time? So let's here, if I run this code and I say for the amount, I gave some garbage, it just says null. And this is not really helpful. So here, what happened was when I tried going into, sorry, up here, this line, I said enter an amount, and I gave it some garbage. That garbage was not a float. And so this line threw an exception. It came and it was caught, and it tried printing the message. Unfortunately, the exception here, the input mismatch exception, does not have an error message. And so the get message prints null. So what I can do is I can, do it myself. So I know this code might throw an exception that doesn't have a meaningful name. So what I can do, and this is not really the best way to handle this code, but here I can try having this code inside of a try catch. Catch here, the exception that is thrown. Now, float amount, because we're using it, let's move it up here. And and here just be float. Okay. So I know that this is going to throw an exception that doesn't have one. I want to make sure that it, you know, the exception does have a message. So what I can do here is when I come, I'll just throw a new exception. So I'm kind of ignoring the exception that got caught here. I'm going to say must enter a number. And now when this exception gets thrown, it's going to get caught by the outside exception and it's going to print the message that's coming from here. Let's give it a try and see what happens. Now it says must enter a number. So the message that came from this exception is being caught by the outside exception. Now, like I said, this is not the best way to write code, but this is one way you can handle exceptions that don't have error messages, that don't have a message for you to print. You can use a nested try catch so that when you try this code and you catch an exception, you throw your own meaningful exception. Finally, when we're doing Java documentation, when you throw an exception, you should add a tag for it so it shows up in the documentation. So let's go to our bank account. And we learned when we want to write Java documentation, what we do is we put the the forward slash and 2 asterisks, and that automatically generates some tags for us. So, you know, bank account constructor. Then here you can give descriptions for your parameters. So here, because I have 2 parameters, it gave me the 2 parameters. And then you can here say what kind of exception you are throwing. So I can say exception, bank exception, for example. That tells what the problem is. Now here I did throws exception initially when we were throwing an exception, but because here it's a balance exception, I can also make sure that I change it to balance exception. So here instead of exception, I can say throws balance exception. Both will work. You know, balance exception will work and exception will also work because of polymorphism. But you can also show it in the Java documentation, and the tag is @throws. So this is the end of chapter 11. So for the classwork, you will again download the student.java file attached to the classwork on Blackboard and use its main. What you're going to do is you're going to modify the student constructor to detect if any line contains a grade less than 0 or greater than 100. Where are you going to do that? You're going to do it in the constructor. So just like I did it in my bank account constructor, I modified it to make sure the balance was greater than 0. You're going to do the same for the student constructor. You're going to write your own exception class to handle that, and then make sure you modify main so that it prints the right message depending on the option. And then also there's a homework assignment for this chapter.